Hi and welcome to John's Maths Book. In this video, we're going to be looking at finding the angles of a right-angled triangle using trig functions when we know two of the sides. If you like the video, then please hit the like button and I'd be honored and delighted if you'd subscribe to the channel. Without further ado, let's go over to the whiteboard. We saw in our previous video how we could use trig functions to calculate the length of a side of a right-angled triangle if we had one of the angles plus one of the sides. So in this video, we're going to be looking at finding the angles of the triangles, and we know the length of two of the sides. Again, we'll be using our memory aid, SOHCAHTOA, to do this. So let's start with this triangle up on the left, where we have a right angle, and we know two of the sides, one's 12, one's 10, and we're trying to find the angles alpha and theta. So let's start with alpha. Alpha, what do we know about the angle alpha? Well, if we look across to the sides of the triangle, we have the opposite side here, and we know the length of that. So the opposite side is 12, and we know the adjacent side marked here. The adjacent side is 10. So if we use our memory aid and look at what involves opposite and adjacent, tan of alpha is equal to the opposite side divided by the adjacent side. And we know the opposite side, it's 12, and we know the adjacent side, which is 10. 12 divided by 10 is 1.2. The tan of alpha is equal to 1.2. So now how do we calculate alpha? Alpha is equal to the inverse tan of 1.2. So if you get your calculators out and see what the inverse tan of 1.2 is, you'll see that it comes to 50.19, and that's in degrees. So the angle alpha in our triangle is 50.19 degrees. Let's now look at theta. So what do we know about theta? So the opposite side of theta, so that's this side, is equal to 10. And the adjacent side, that's this side here, is equal to 12. So looking at our memory aid, we have an opposite and adjacent. Opposite and adjacent relates to the tangent of the angle. So the tan of theta is equal to opposite divided by adjacent, which is equal to 10 divided by 12, which is equal to 0.83. We have our equation. Theta is now equal to the inverse tan, the tan to the minus 1, 0.83. So if we get our calculators out again and work out what the inverse tan of 0.83 is, we see that theta is equal to 39.81 degrees. Now let's take a look at our second example, where we have a right angled triangle. We know two of the sides, one is 11 and one is 15, and we want to find the angles alpha and theta. So let's start with alpha again. We have the two sides of the triangle that we know. One of them is the hypotenuse. The side labeled 11 is adjacent to the angle alpha. So we have the adjacent side is equal to 11 and the hypotenuse is equal to 15. So using our memory aid, we have adjacent and hypotenuse relates to the cosine of an angle. The cosine of alpha equal to the adjacent side divided by the hypotenuse. The adjacent side is 11, hypotenuse is 15. 11 divided by 15 is 0.73. So we have an equation where we have the cosine of the angle alpha is equal to 0.73. So alpha is equal to the inverse cosine, cos minus 1 of 0.73. Again, if we get our calculators out, so the inverse cosine 0.73 is 42.83. Now looking at the angle theta, what do we know about theta? Well, we know its opposite angle, marked here, is 11. And in addition, we know the hypotenuse as before, and that's 15 in length. So we have an opposite side and a hypotenuse side. So opposite and hypotenuse, using our memory aid, relates to the sine. So let's mark these in. So we have opposite is 11 and hypotenuse equal to 15. The sine of theta is equal to the opposite side divided by the hypotenuse. So the opposite side is 11 and the hypotenuse side is 15. That equals 0.73. Theta is equal to the inverse sine of 0.73, which equals 47.17 degrees. So that concludes this video on finding angles of a right-angled triangle, given that we know two of the sides of the triangle. And so see you next time. Bye for now.